This is a quick tutorial to find critical values using the tables. So we're looking at critical values for alpha is 0.05. First, let's try to do a t-distribution where n is equal to 15. So with n equal to 15, remember that there's a degrees of freedom involved here. And the degrees of freedom is one less than that, so that's 14. And we want to do a one-tail distribution. So we're looking at the t-distribution at one tail. I guess we should have specified whether it's to the left or to the right. Let's assume it's on the right, so it'll be a positive number. And then we have the area is alpha, 0.05. So we pull out our table, and with the degrees of freedom being 14 and the area in one tail as 0.05, we just go down to 14 and 0.05, and then we get a 1.761. So your t here is 1.761. Now we can do the same problem where alpha is two tails, and again we could draw the picture, but this time it's two tails, so we'll have both the positive and negative values involved. And so we look at our t-distribution table again, same 14, but this time alpha and two tails, we're looking at the very middle here, so that is going to be 2.145. And that's your critical value for that. Now if you're looking for the z-distribution, there's a couple of options. One is you can look at table A3 or A2. The other is to use the inverse norm in the calculator. And the third option is also using a table, but using table A3. So if we're looking at one tail where alpha is 0.05, so much like how we found the t-distribution critical value, we can look at this also. Alpha is 0.05 in one tail, but this time if you go all the way down to the bottom, notice that the bottom row of the t-distribution says large, and that value there is the exact same z value that you would have gotten from table A2. So it's 1.645. Similarly, the t-distribution with two tails, so alpha is broken up into two tails. If we scroll up and notice where the two-tail list is, alpha is 0.05 and two tails. All the way down at the bottom again is a z-distribution, that's 1.96. The chi-square distribution will be using table A4. And so if you take a look at the chi-square distribution, remember that it starts at 0, it goes up, and it's usually skewed to the right. And so let's assume that this one tail is on the right side, and this is 0.05, and the area to the right here is 0.05. So your chi-square, and we have to call this chi-square r. I guess we don't need to label it r or l, but since it's on the right side, we might as well look at it as chi-square r at 0.05, and the degrees of freedom is one less again, one less than n. So if we get our table out, this time we have to go to table A4, and we're looking for a degrees of freedom of 14. So that would be this row, and the area to the right is 0.05, so 14 to 0.05 is 23.685. Now we can do the same problem if we go to the left And if the area on the left side is 0.05, then that means the area on the right side is the complement of that, or 0.95. And that's what we'd be looking at. So for this chi-square left value, critical value, for the one tail, we look at our table in 0.95. If you notice, that's pretty symmetric about this table, 0.05 and 0.95. And degrees of freedom is 14, will give us a 6.571. Okay. Now let's take a look at the last problem where we have, this should be a two-tail, a chi-square distribution in two-tail with alpha is 0.05. So 0.05 cut into two tails means that your alpha is going to be cut in half. So alpha is 0.05, and so the area here will end up being half of that. So area is 0.025, and so you'll have an area of 0.025 here as well. And so you'll have two critical values, chi-square L and chi-square R. And we're looking at the area to the right, so if we look at the table with the area of 0.025, we'll get chi-square R. If you look at the table with the area of now this and this other area has to make 1, so this is 0.975, so that when you add these two things you get 1. Then we're going to look at the table and see the symmetry in the table. We're looking at 0.025. This is the third from the middle, and then the third from the middle going in the other direction is 0.975. So with degrees of freedom being 14, we got 5.629. And for the right side, degrees of freedom 14, we get 26.119. Okay, so these are critical values, and that's how you find the critical values using the tables.